In the circuit shown, the threshold voltages of PMOS and NMOS transistors are both equal to 1 volt. All the transistors have the same output resistance, that is RDS of 6 mega ohms, which is nothing but R naught. The other parameters are listed below. Mu Cox for both PMOS and NMOS are given, and W by L of PMOS and NMOS are given. And mu N and mu P are the carrier mobilities, and Cox is the oxide capacitance per unit area. Ignoring the effect of channel length modulation and body bias, the gain of the circuit is dash. So first thing that we observe here is the input is applied to this Mosfet, and the load is basically this PMOS, which is actually biased with a voltage coming from this two transistors in stack, which are diode connected. The voltage that is coming at this PMOS transistor, which is the load, is going to be a fixed voltage, which means this MOS transistor, this PMOS transistor, let me call this as M2, this is M1. M2 is going to be like a current source. When it is like a current source for AC analysis, obviously it will be represented with a simple resistance, that is R0. M1 will be like this, where its CLM effect is shown outwards, that is again R0, which is given. Now VDD will be grounded because it's a small signal analysis. Now we need to find what is the gain of it. So obviously because of this VI, there will be current flowing here, which will be GM times VGS, which is VI. That GM times VI will be flowing through both the resistances, R0 in parallel with R0, and the output voltage is taken here. So this is a common source stage where output voltage will be minus GM times R0 in parallel with another R0, where they have given all the transistors have same output resistance, hence we are taking both as R0 itself, times VI. So the voltage gain will be minus GM times R0 in parallel with R0. R0 is 6 mega ohm. 6 mega ohm in parallel with 6 mega ohm will be 3 mega ohms. Now we need to find what is GM. So in order to find GM, we need to know what is the VGS value, right? Because GM is given by mu Cox. This GM is for the NMOS transistor. Hence this is mu N Cox W by L of N times VGS minus VTH. To find this, first of all, what we need to do here is we need to find the current that is flowing through M2, because that is easy to find, because we can find what is the voltage at the gate of M2. To find that, we have two diode connected transistors stacked, which means both PMOSs are identical and they are in saturation because they are diode connected. How can we say they are in saturation? Because 4 volts is definitely greater than 2 times the threshold voltage of PMOS. Hence both the diodes should be on. Once they are on, they are in saturation region. As both are identical, voltage across this transistor should be equal to voltage across this transistor, as they are going to allow same current to flow through. So hence this should be 2 volts, this should be 2 volts. If that is the case, this should be equal to 2 volts. We know that current flowing through PMOS transistor M2 and NMOS transistor M1 should be equal. So let me write mu Cox W by L of N, this is mu N, times VGS N minus VT whole square by 2 should be equal to mu P Cox W by L P VGS P magnitude minus VT P magnitude whole square divided by 2. We know mu N Cox W by L of N is equal to mu P Cox W by L of P. So hence we can cancel both of them and 2 here. So if this has to be equal, which means VGS N should be equal to VGS P magnitude. VGS P magnitude we know is 2 minus 4 magnitude, which is 2. Hence VGS N should be is equal to 2 volts. Now we can find what is GM of the NMOS, which is mu N Cox W by L of N times VGS minus VT. As we know, VGS N is 2 volts, 2 minus 1 is 1 volts, and this entire thing is given by 60 times 5, which is 300 microampere per volt square. Vgs minus Vt is 1 volt. So we get Gm is equal to 300 microampere per volt. Now the voltage gain A suffix V is equal to minus 300 microampere per volt times 3 mega ohms. Of course, ampere per volt is mho and ohm cancel. We get here minus 900. Even micro and mega gets cancelled. So the voltage gain is minus 900.